Alright, so in this video I'm going to do one more example of using a linear approximation to approximate the value of the square root of 15.9. So again, the idea is kind of the same as in the other example. Again, I'm just going to draw a little graph just to hopefully make a little extra sense out of what's going on. So the graph that I'm going to draw, we're trying to take the square root of a number. Well, so I'm going to draw the square root function. And y equals square root of x just looks something like that. So again, what we're trying to do is we're trying to take 15.9 and we want to plug it into our function and get the true y value, right? So here's 15.9 comma the square root of 15.9, whatever that value is. I would like to know that exactly, but since I can't figure it out exactly, again, in this case, we're going to use a tangent line approximation. So the idea is, well, I'm taking a number close to 15.9 that I can take the square root of, like 16. So this would just be the point 16 comma 4. Well, if I can find the equation of that tangent line, so the tangent line, here's my rough-looking little tangent line. The idea is the y value on the tangent line, again, is close to the true y value. So again, what we're going to do is we're just going to find the equation for that tangent line, and then once I have the equation of that tangent line, we'll just plug in the value 15.9, and that will be our approximation. So okay, the equation of the tangent line, it's going to be y minus the y coordinate. Again, we'll have to figure out the slope, x minus the x coordinate. To get the slope again, we just have to take the derivative. Okay, so we'll have to take the derivative, and in this case, we'll plug in the x-coordinate of 16. Well, we've got our function up here, f of x is just x to the 1/2, or square root of x. When we take the derivative of that, we'll just get 1 over 2 x to the, well, we have to subtract 1, so 1/2 minus 1 will just give us to the negative 1/2. And then we can rewrite this as 1 over 2. We can put the x to the 1/2 in the denominator. And again, that's the same thing as 1 over 2 times the square root of x. Well, okay, easy enough. So that means if I plug in 16 into my derivative formula, we'll have 1 over 2 times the square root of 16. Well, the square root of 16 is just 4. So we've got 2 times 4, or 1/8 as our slope. So all I'm going to do is just rewrite the equation of my tangent line here, fill it in completely. So we have y minus 4 equals, again, so the slope is going to be 1 over 8, and then x minus 16. And I'm going to clean this up a little bit. I'm just going to put it in slope-intercept form. So if we distribute the 1/8 times x, that'll just give us, well, 1/8 x. We'll take 1/8 times negative 16. Well, that'll give us negative 16 over 8, or negative 2. And then we'll add to that positive 4, so we'll add the 4 over. And it says, hey, y will be equal to 1/8 x. Negative 2 plus 4 will just give us positive 2. So now we've got the nice little equation of our tangent line. Okay, so the equation of our tangent line here is y equals 1/8 x plus 2. And now we're going to do just like we said. I would like to know the true y value, which is, when we plug 15.9 into the square root function. Well, in this case, since we're approximating, I'm just going to plug that same x value, 15.9, into our line equation. And that'll be our approximation. So it says we'll get 1 over 8 times 15.9 plus 2. It was probably actually easier to evaluate it before we multiplied things out. So I'm going to go back and actually plug it in there. This line and this line are the same. But notice if we plug it in here, we'll get y minus 4. We'll just get 1 over 8. And then we'll get 15.9 minus 16 when we plug it in. Well, I think that's a little bit easier to do. So we have 1/8. Let's see, 15.9 minus 16, that'll be negative 0.1. Well, let's see if we can't clean this up without a calculator. So negative 0.1, well, that's just negative 1 over 10 if we rewrite it as a fraction. So if we simplify on the right side, I guess we would get negative 1 over 80. And then we can add positive 4 to that. Well, we can keep simplifying here. So I guess we can get common denominators, multiply top and bottom by 80. So if we multiply top and bottom by 80, 4 times 80 is going to give us 320. So it looks like at the end, so 320 plus a negative 1, that'll give us 319 over 80. And since I've got a calculator right here beside me, I'm going to go ahead and turn that into a decimal. So 319 divided by 80, I'm getting 3.9875 and then a bunch of zeros. So the idea is, again, we've approximated, so we found the y value on our line. The y value on the line, again, is 3.9875. So we can say 3.9875 is roughly equal to the square root of 15.9. And just to see how close we are, again, since I have my little calculator here, so if we take the square root of 15.9, I'm getting this to be 3.98748041 da 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 da. So, you know, pretty close. It agrees with the first 3 decimal places exactly, 987. And then, you know, we've got a 5, and here we've got a, 48. So it looks like our approximation is, in fact, pretty darn good. So, again, though, you can tell from the geometry, we could have easily, another number I could take the square root of would be 25. But the idea is you don't want to use that tangent line, because by the time you get to sort of the y value that you're interested in, it's going to be that line is going to be certainly much further away than the tangent line at this point using 16, 4.